All right, yeah, welcome back once again. My name is Victor Digomore here, and like we promised that we are going to be solving the questions in the last concluded WAEC 2025 mathematics. That is what we want to start doing. We have the theory part, which is where I want to start from. This theory part comprises of section A and B. In the section A, we have 5 questions here, and I'm going to be solving these 5 questions. So the first question number 1 here says, given that U is a universal set such that S is greater than 1 and less than 20, where X is an integer, it has a subset P such that P is a multiple of 3, and Q such that Q contains elements that are prime numbers. Say where P and Q are subsets of U. Say find these expressions that are given here. So let's quickly see how we can be able to answer this question number 1. The first thing we do is to make a list of the elements of the universal set U. Says we have this universal set to be comprising of elements X such that, okay, such that 1 is less than X less than 20. You need to understand the meaning of this statement. The meaning of this statement is that U will comprise of these elements 2, 3, 4, comma, then 19. Why? The thing is this. Look at this inequality. The inequality says X is greater than 1. And for you to say X is greater than 1 is not inclusive. For you to say X is less than 20, it means that 20 is not inclusive in the elements that are in this universal set. I just believe that explanation is clear. This range shows that the lower bound and the upper bound is not inclusive. But if you were given something like less than or equals to, in fact, in some instances, can be greater than and just less than or equals to. So the implication of this one is that the upper bounds are inclusive. So when I'm making a list, I will start from 1 and stop at 20. But this other one, the implication is that 1 is not inclusive, 20 is not inclusive. So I'll start from 2 and stop at 19. That's the implication. So I just believe that this explanation will help us to now look at the other subsets that are in this place. They say that there is a subset P. There is a subset P, and this subset P comprises of elements X, such that X is a multiple of 3. So all the multiples of 3 that exist within here will be 3, 6, 9, 12, 15, 18, nothing more, because these are the elements that are within this range of description. Then we have also another subset Q, and they say that that Q contains elements that are prime numbers. So we have elements that are prime numbers that are in this universal set will be, of course, 2 is a prime number, 3 is a prime number, 5, not 6, 7, not 8, not 9, not 10, 11, 13, 14, 15 is not there, 16 is not there, 17, and 19. These are prime numbers. What are prime numbers? Prime numbers are numbers that has 2 factors, itself and 1. So they now ask us to obtain a P intersection Q prime. This statement here will make us to look for Q prime. So let's look for Q prime. Q prime, elements in Q prime. This thing, we call it a prime or complement, meaning elements that are in the universal set but they are not in Q. They are not in Q. Elements that are in the universal set but they are not in Q. How do we find them? The way we are going to find them is simply to go to this. We simply go to this element subset Q. We simply go to this subset Q and begin to check what is in the universal set but are not here. So if we go there now, we realize that the first element will be 4, followed by 6, followed by, after 7 we have 8, we have 9, we have 10, 11, we have 12, 13, 14, 15, 16, and 18. These are the elements that are in Q prime. They are in the universal set, but they are not in Q. Look at Q here. They are not here. So if you check, all these elements are not here. They are called Q prime, Q complement. Okay. And I'm also seeing that in the next question there is need for a P prime, that's P complement. So let's at the same time get all the P complement. The P complement, which are elements that are in the universal set, but are not in this P. So let's count P and use it and check. 2 is not here. 3 is here. 4, 5, before 6, 7, 8, then 9, we have 10, 11, 12, then 13, we have 14, 15 is there, we have 16, 17, 18, then 19. Okay, 19. So these are the elements that are in P prime. They are in the universal set, but they are not in P. They are not here. So having gotten this now, we can now be able to answer the question that says obtain. So what will be P intersection Q prime? We'll be explaining these concepts alongside. Okay. What is the concept of intersection? It shows that what are the elements that are here in subset P and also in subset Q prime. That is the elements that are here and they are also here. So we can be able to trace them. We can trace them. If you look closely, you see that 6 is here and 6 is here. So we write 6, comma. We can also see that 9 is here, 9 is here. Have 9. And then after 9, what again? 12 is here, 12 is here. We have 12. We have 14 is not there, 15 is here, 15 is here, 15. What again? 18 is here, 18 is here, so we have 18. So these are the elements that are here and are also here. Okay. What about then B says P prime union Q. P prime union Q. The element that, what is a union? That's the first thing we need to understand. A union is simply the total listing of elements that are existing between two subsets without repetition. So when I'm listing it, I'm not going to repeat. Okay. So if I come here, look at P prime. They're listing all the elements that are here in P prime and also in Q. This and this, this and this, without repeating. So as 2 is here, 2 is here, I will write 2 only once. I'm sure that is taken. So, but I will list all the elements without repetition. So that union of this and this will be 2, 2, comma, 3 is there, 4, 5, there's no 6. So I'll go to 7. After 7, I have 8 here. After 8, what again? There's no 9. So I'll go to 10. After 10, 11, 13. There's no 12 here and here. So I will write 13. After 13, 14, followed by, there's no 15 in both of them. So I will write 16, which is here. 17. Then there's no 18 in both of them. So I will write 19. These are the elements, union, total listing of the elements that are here and also here. I believe that is very, very clear. Okay. So having taken this into cognizance, The last one will be C. C says obtain bracket P union Q. P union Q prime. But before that complement, let me obtain P union Q, then look for its complement. So, but for P union Q, the union of P and Q is this and this. So I'll start with 2, 3, 4. After 4, no, there's no 4 there. I'm looking at here and here. 2, 3, 5, 6. Okay. 2, 3, 5, 6. After 6, we have 7. We have, there's no 8 between them, but there is 9 here, followed by, there's no 10 between them. I will have 11 and 12, comma. After 12, 13. There's no 14. Then I write 15. After 12, 13. There's no 14. I will write 15. I will write again 17, 18, and 19. This is the union of these two sets. And after this union, I will now check elements that are in the universal set but they are not here. They will be my P union Q complement. I hope you saw what the procedure I followed. So this will become elements that are in the universal set but they are not here. I will be checking along this line. So we'll not write this 2, 3, 4 will come in, 5, 6, 7, 8 will come in, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So these are the, how many are there? Let me check again. 2, 3, 4, 5 here, 6 is here, 7 is here, 8, 8, 9, there's no 10, 11, 12, 13, there's no 14, 15 is here, there's no 16, 17, 18, 19. Okay, so these are the elements that are in this this expression. These are the elements that are found there. Okay, we have been able to answer the questions that are given in this case, but I will just give us a little bonus. That little bonus is, peradventure, one is asked to present this same, or the D part of the question says put this information in a Venn diagram. How is it going to look like? So if you want to put this in a Venn diagram, the universal set and the two subsets, you realize that you have two subsets there. I'm sure you have seen P and Q only. There is no PQR subsets. Only two subsets we have. So we will have P here and Q here, the universal set of elements X such that 1 is less than X less than 20, where X is an integer. And then what is existing, this space here is for an intersection. I'm too fast to put them together without checking. You need to check first if there is an element that is here and it's also here before you can bring this space. Otherwise, they will be disjointed. That's to say, this one stays separate, this one stays separate. I'm still going to make out time to do a complete class in the theory of sets. So if you're with us, you see when we start that. So this space here shows an intersection, and it simply conveys to us that the two subsets has elements that are common to each one of them. If you look here, you see 3, you see 3 here. I don't think there's any other thing that is common among them. So we will put only 3 here. and then list the rest. For P, the ones that are not only in P will now be 6, 9, 12, 15, and 18. The ones that are here will be 2, 3 is already here, 5, 7, 11, 18, 17, and 19. So, but the question is that, is all these things all the elements that are in this universal set? The answer is no. There are some that are not here, like if you start from the smallest, which is 2, and begin to check line by line to 19, you begin to check 2, 3, there is no 4 within here. So 4 will be outside here. 5 is here, 6 is here, 7 is here. There is no 8, so 8 will be outside. What about 9? 9 is here. 10, there's no 10 anywhere, so 10 will be outside the 2 subsets. What about 11? 11 is here, 12 is here, 13 is here. What about 14? 14 is nowhere to be found, so 14 will be outside. 15 is here. What about 16? 16 is nowhere to be found. 17 is here, 18 is here, 19 is here. So these elements here are the element that does not exist in either of these two subsets. So it's a way of presenting, it's just a bonus I gave. Okay, it's a way of presenting this information in a Venn diagram. Okay, so I believe we are going to go over to solving the remaining 4 questions that are still left here. But please, you have to subscribe to the channel, like our videos, and click on the notification button to be able to know the updates, the uploads we are going to be making. Please like what I'm doing and share to your friends out there. And I believe this lesson must have added knowledge to you. And if you subscribe to our channel, you are just trying to encourage us to do more. I believe you are going to do that. Thank you for being there.